everyone, welcome back to the channel. Today we're going to talk about merge sort. So as usual, let's start with a one-sentence summary of the algorithm. So merge sort is basically having an unsorted array, try to sort the left half, sort the right half, and then merge them together. And we have a sorted array as the result. Sounds simple, right? So let's work on an example to figure out how merge sort actually works. So we have this unsorted array here. The first thing we want to do in merge sort is to copy the array we already have. So we copy it. Note that I didn't write anything on the original array down below because let's think of the original array as the place to put the new information in and the copy array as the place to retain old information so that we can sort the array itself. The next step is to find the middle element. So the middle element is here, the 0th, 1, 2, 3, 4th element. So we have 9 elements, this is the middle. The left half would go from low to mid, and the right half would go from mid plus 1 to high. So we have the two halves here. To demonstrate the merge idea, we would assume that somehow magically the left half is sorted, the right half is sorted, and then we will try to merge them with each other. So assume we have the two halves as follows. They are each sorted. And don't worry, we will talk about how to sort the whole array very soon. So this is the two halves. We use ijk as a way to keep track of which element we're currently at. Okay, let's now merge. So k is to help us keep track of where we are in the resulting array. I keeping track of the left half, and j keeping track of the right half. So for the first position, 2 and 4, 2 is smaller, so we know 2 goes there. Then we increment I. Now for the next position, j is smaller, put it up there, increment j, and then look at the next element. These two, 9 is smaller, so 9 goes here. Increment I, consider the next element. 11 is smaller, great. Increment j, look at the next element. 19 is smaller than 25. Put it there, increment I, increment k. 24 is smaller, so increment I, increment k. 25 at 47. 47 is smaller. Increment j, and then for the next element, 36 is smaller than 47. So we run out of elements on the side. So we know whatever that remains on the left side would go to the remaining positions. Great, so they are all sorted. Note that this only works when we have two sorted halves. This is because we take each element as we have done, right? So it wouldn't work if either of them is not sorted. Now let's look at the code together. So the merge sort code has 3 functions in it. We have merge, we have merge sort helper, and merge sort. So whenever we call merge sort, then it will call merge sort helper with a, the array, low as 0, and high as length of a minus 1. So for merge sort helper, if the array has 0 element or 1 element, we don't really need to do anything because it's already sorted. Then we would just return. We then, for other more interesting cases, we find mid. Then we try to sort the left half, we try to sort the right half, and we merge them with each other. For merging, first we create an auxiliary array. Then we use I, starting from below, to keep track of the elements in the left half. Use J to keep track of the right half. Then for each element in the range low and from low to high plus 1, that is not including high plus 1, if I is bigger than mid, then all elements in the left has been exhausted, so we just take all the things from the right and put it to the resulting array. Similarly, if the stuff on the right has exhausted, then we take all the elements from the left to the array. When the right element, the element on the right is smaller than the corresponding element on the left, we take the right one and put it in the correct position, and don't forget to increment J. Similarly, when I is smaller than or equal to J, the element at the 2 positions, then we put the element at the I position first and increment I. So that is the code for merge sort. Now let's look at an example. So coming back to our unsorted array, we will now try to see how merge sort works from the beginning. So we have an array, then we split it into 2 halves, left and right, and then we try to sort the left half first, right? So let's try to sort the left half, and the right half should work the same, and then we have done the sorting of the 2 halves, as in merging of them in the beginning. So for the left half, we have these, and then we continue to split them. Then we continue to sort left half first, continue to split the left half. Hope it catches on the camera. Great. And then left half. And then we merge them back together. 2 first and then 19. Merge these. Merging them. And then we're good. Let's try to sort the right half. So sort the left, split them, and then sort them back because they're already sorted because there was just 1 element. And then we sort them back like we have done at the beginning. So we have 3 iterators. Remember our iterators. Let's use it. J and I. Okay, it will be super quick. So for the first, I smaller. For the next one, 9 smaller, right? So put it here. For the next one, look at the K, so don't be confused with all this. 19. Great, increment I, K, 24, and then we run out of this, so we just put it back. So as you can see, we have the sorted left half. I'm sorry, I just touched the camera, it's shaking. So we have the left half right here. Then do a similar thing with the right half, and then we should be able to merge them as we have done in the beginning. Now let's look at analysis. So merge sort is a stable algorithm. This is because when the 2 elements from the left half and the right half are equal, we would choose the left half, as we can see in this else statement. It is not in place because we use an auxiliary array to help us with sorting. So imagine if we have a billion element array, then we also need to create another array of a billion elements to help us with sorting. The time complexity is O n log n in all cases, so we have a guaranteed performance. It is O n log n because this is a divide and conquer algorithm. We try to split things in half and technically making the problem smaller until we can solve it, and then try to merge them with each other as we move back from the smaller problems to the bigger ones. So that is the analysis of merge sort. If you have any questions, again, feel free to leave it in the comment section. Thank you for watching and see you next time.